Hello and welcome to Noel's RetroLab. Today we're going to go back to the TI-99 48 that we had a couple episodes ago, and I just got some parts that we needed, specifically the SRAM that we had been waiting for. So let's put it in and see if that finally fixes everything. And here we are, back with the TI-99 48 that it's given us somewhat trouble. So last time we had removed those two SRAM chips because we thought they were potentially preventing the computer from starting up correctly. And I have just received a new set of them. So hopefully these are not fake chips like we saw in some of the other videos. They came from a reputable UK seller, so hopefully that's okay. So let's go ahead and pop this in and try it. But before we do that, I'm going to mark these two with maybe a question mark because we don't know if they are working or not, but at least we won't get them confused with the other ones. They look very different from those, but you know, they were manufactured even a different year, so hopefully that's okay. We already have sockets in place, so it's just a matter of popping them in. Since I still haven't hooked it up to video out, because this only outputs component video and this is a little trickier, we can check to see if it's working, or at least better, if it's working better than it used to be, by seeing if we get that sound, which was, I remember, was at the right there in that inductor. So please no. Oh, that doesn't look good. That looks like a sound signal to me. So yeah, we still haven't gotten past the initialization process. Bummer. Okay, so I just did a few checks off camera, checking the buses again. And the address bus looks perfect. Here, let me just grab a random bit. It should be between 10 and 24, like right there. Well, we're really zoomed out. And that looks totally fine. And you look at the next bit. So all of them look perfect. The data bus looks fine in the lower half. So bits 0 through 8, which correspond to that particular ROM, they'll look perfectly fine. So if I grab one of them, and you know, this is just an example, but there you go, that looks fine. This box is a little weird, but yeah, that's fine. But we're going back to the upper data bus, so the one that corresponds to this EPROM, and one of those two SRAMs, and a few other things. Some bits are fine and some are not. So let's see, start in bit 9, and that right away just looks bad. And those little ramps like that, to me, it seems like something is fighting there. That's fine. Although every so often it flashes one of the other ones, but again, that looks a little bad. That one in particular just looks horrible. It looks like something is really fighting to drive something while it's grounded, and that one is half and half. That one seems fine. Yeah, that one good again, and I think we're done. Yeah, maybe this is the last one. And then, yeah, ground. So yeah, the data bus in those upper bits just does not look good. Okay, given that, let's go ahead and remove the buffer and the flip-flop from the upper bus. In that way, once I remove the SRAM as well, which is already socketed, we'll be able to see if those lines are still being held low. And if so, it probably means that we need to replace the CPU because it's the last thing left connected there. So let's give that a try. It's actually interesting how bent the pins are. I'm not used to them being this way. Normally they're more like that. They're more straight down, but here they're actually really bent. So after desoldering, you really need to go with the iron and just make sure, not just that they're loose like I normally do, but make sure that they're pointing up, because even if you remove all the solder, they'll be hooking on to the edges of the eyelets like that. Yeah, just like that. Wow, that came out nice and easy. And same thing with that one. Nice. Sometimes these old boards can be pretty challenging to remove chips, but this was beautiful. Speaking of old boards, in this particular one, in the TI-99 one, there's one thing to watch out for that if you've seen Adrian's Digital Basement video, you may remember, which is they don't use mask on the tracks when they go in between the pins. I guess maybe that was a limitation of the technology at the time, since this is a pretty old board. It's probably was maybe made in the late 1970s, really early 1980s. And so they probably just masked it out with a square. And so if you look closely, yeah, there the tracks between the eyelets don't have any mask. So if you add a lot of solder and you're not careful, you may get shorts in there. And some of those lines, like we've seen with Adrian, they could be the 12-volt line and really bad things happen. And even it's not just on the underside, it's on this side as well. So if you have a lot of solder that flows through, you may have the same problem. So I think what we're going to do is we're going to put sockets, we're going to solder it as carefully as we can, and then I'm going to check continuity. I'm going to check that there are no shorts in between adjacent pins. That looks pretty good, and I don't see any shorts, but I'm gonna check anyway. Okay, and I'm also gonna check the individual tracks. So like that to that. Okay. With those buffers removed, we're going to test the data bus again. So just grab some random one in there and turn it on. Ugh, that kind of looks the same. Yeah, that don't look very good. Yeah, look at that. Okay. One last test before we decide that it's the CPU, which I'm not looking forward to either buying a new one or replacing that one. There's just so many pins. So what we're going to do now is I'm going to remove the SRAM. So there's really nothing else connected to the bus. And I'm going to put an EPROM that has been fully erased. So it's all FF. So no matter what, we should be seeing some high bits on that data bus. Let's try that. All right, there we go. This is the data bit that was staying low all the time. And now it's high all the time. That's interesting. They're all high, which they really shouldn't be high all the time. Oh, this is low? No, it's also high. I would have expected them to go up and down depending on chip enable. But I suppose that maybe it's a tri-state and so there's nothing holding it down and it's just giving FF. So maybe this is correct. So this is output enable, and that's what I would have expected this to match. But it seems that we always have high bits. Which at least is what's in the EPROM. Ooh, not here. Why not here? So that's what I was expecting to see. And this is the first, yeah, this is the first bit of the data bus in here. Now over here is the address bus. So that's kind of what I was expecting to see everywhere. Not this. Okay, so now I've hooked up both channels on the oscilloscope, and one of them is permanently hooked up to chip enable, just to see if we can see a pattern with, so there's chip enable, and this was the first bit of the data bus. And there's a very clear correlation there. So chip enable is active low, right? This is chip enable, and that goes first. When that goes low, the output goes high. And then when this goes away, that goes low. That's kind of what I expected. But seeing this, is just a little weird. But as I said, maybe it's a tri-state. So the question is, why is data bit 9 on the data bus being driven low and not the others? And I guess that could be some other logic on the board that is doing that. But at least those are not permanently low like they were before. So unfortunately, I'm not convinced that the CPU is faulty. So far it's behaving okay. So there's one more test I want to do before we get into more complicated things like starting to replace the ROM with our own code. And it's something that worked well for Adrian over at Adrian's Digital Basement, which was to apply a cold spray in the CPU. And he actually had a very similar problem with some of the data lines stuck on high. So we can do that while we're looking at the data lines and then see if we see any difference, any changes at all. So turn it on. Going to, for example, look at this one. Okay. And now I'm going to apply. And it doesn't seem to make any difference. You can see the ice in there, but this is totally the way it was before. And that one is kind of what I expect to see all the time. But the other ones are not behaving that way, and just cooling down the CPU, as you see, is not making any difference. So I'm definitely not going to just say it's the CPU. It could be something else. So at this point, I reached out to a TI-99 expert, and that is Eric Peel. He did the FPGA implementation of the TI-99, so he's intimately familiar with this whole architecture. So we were talking a little bit about what I had done and what I had tried, and he casually mentioned, oh, by the way, you do know that the higher bits of the data bus, so D8 through D15, are considered the low data bus, right? Not the high data bus. And I went, oh no, I didn't realize that. So I might have messed up a few things. Maybe I used the wrong ROM when I burned that into the EPROM. So let's go back and recheck all of that. I just got these adapter PCBs to connect an EPROM into the ROM socket of the TI-99 4A. And I still don't have an EPROM that I can burn of the correct format, but maybe I can use them to read the contents of the existing ROM and compare it against the EPROM that I burned. They're super simple, just a PCB, a socket, and some pin headers to connect it to the board. So let's go ahead and build it. Here's the finished adapter, and yeah, this is way better than that nasty stack of sockets that I made last time, but that's the advantage of having a pre-made PCB, just condenses a lot of things. So this is not exactly what I want. So this is an adapter that lets me, and it says it right there, lets me plug in a 2732 EPROM in here and put this in place of a 2532. Now, what I really wanted to do right now was to read this on an EPROM programmer, but unfortunately, the connections are not exactly symmetrical. So I can't just put this here and tell this to read a 2732. What I can do, however, and I just did, is build this mirrored. So the PCB is really intended to go both ways. You just need to put the socket here of whichever one you want to read. So if we want to use a 2532, just put the socket over here. If we want to use a 2732, just put the socket over here. So this I should be able to use, put in the ROM right there and reading it like this. Let's give that a try. So let's try reading the data in that ROM and comparing it against what we expected to have there. Let's see if that was working or not. So I'm going to select a 2732, doesn't really matter which one, turn off pin detect, and I'm going to do a read. And let's just see if it works. Okay, so it worked, it didn't give any errors. That's a pretty good sign. and we got some data there. So one thing I can do, I can either diff this, or what we can do is we can actually load the high bus ROM and then do a verify and see how it compares. And it fails. And yeah, look at that. All of it is wrong. So chances are I selected the wrong ROM to burn to that EPROM. So maybe it's already working and I just put the wrong values there, which obviously will never allow the computer to start up. So let's see if this ROM is working. Let's compare it against the other ROM. And oh wow, look at this. So I was just reading 99 for a ROM, high bus, and I was stopping there. What's afterwards? U610, U611. It's telling you which integrated circuit that is supposed to go into. And the one that we have here right now is U611. So yeah, I definitely chose the wrong ROM to burn. So I've just loaded that one. Let's verify it. Let's compare it against the contents of this one. And look at that. It completely passes. The ROM seems to be perfectly fine. We didn't need to make that huge stack. Hey, at least I haven't unsoldered the other one. So that's something. Okay, well, knowing that now and knowing what the high bus and the low bus is, let's put it back in and try it with the new SRAM, which maybe that's the only faulty part in the system. Okay, so let's pop in the ROM back in place. And actually, I should remove the X because we know that it's working. And I guess I'll remove the H for high as well, since we know that's not right. And besides, I only have one socketed for now, so that's not too much of a problem. And in it goes. All right, so since we put everything back together, if we're lucky, this could work. This is actually the initial configuration with the new SRAM. So what I'm going to do is I'm going to check directly the sound that we were getting earlier. And let's see what happens. And that doesn't look like any sound at all. That looks... wow. Let's look at the video signal itself. And let's see, it should be this pin. And that looks like a good video signal. That's way better than before. So yeah, I'm really thinking that this is actually started up correctly, and I'm hoping we're actually seeing the startup screen. So wow, after all this time, it was the SRAM. And once we get the video working, I'll go back and see if both of them were bad or not. And that makes sense, because one of those being bad definitely did affect the whole data bus. And that's what made me start chasing down the ROMs first. But you just never know when electronic components are all connected to the same place, then they could all be affecting that particular connection. So it looks like it was the SRAM in this case. Well, I'm really glad that we made it this far. Now let's see if we actually see the startup screen. The TI-99 4A uses a 6-pin DIN connector, or at least the PAL version does. The NTSC version uses a DIN 5 connector. And unfortunately, the signals coming out of that connector are not composite video or RGB video. Instead, it's component video, which is not the easiest video to show in a lot of devices. Component video has a luminance channel in a blue minus luminance and a red minus luminance. So we're going to be focusing for now just in the luminance channel. So here we have a DIN 6 connector, and that's the connector for the PAL video out of the TI-99 4A. And what I'm going to do now, just as a quick test, is only hook up the luminance component, because it has the 3 components. So with that, we'll be able to get a black and white image on the screen and then go from there. If that looks okay, then we can try to get the other two components or do something fancier if the TV doesn't accept it and maybe try to convert it to RGB. So, but for now, we need to do that. So I just need to open this up and following the schematic we saw earlier, this particular connector that carries the luminance signal. So I'm going to connect this RCA jack to the luminance signal and ground, and we'll be able to get the monochrome image from here. There you go. This is obviously all very temporary. I'm not even putting the casing back. So I'm just going to plug it in like this. And now I'll connect the TV cable right there. Okay, with everything connected, let's give this a try, see if we get some video. Yes, yes, we finally get some video. Awesome. Okay, that is so much better. Now we know this, at least initially, it's working. Now we can continue doing other things. So that was it. We finally have image coming out of the TI-99 and it seems to be starting up properly. So apparently it was just the SRAM. So that was an easier fix than I feared, but we certainly took a roundabout route to get there. Anyway, we're going to stop here for now because this is going to continue for a while. This is a PAL system, and getting video out of the PAL system in full color, it's not trivial. So we'll save it for our next episode. Hopefully we'll get nice RGB out and do some software testing and maybe get a little bit more in detail in the architecture of the TI-99. Anyway, I hope you enjoyed the episode. If so, please give it a thumbs up as usual and subscribe to the channel. Until next video, see you then.